Hello everybody, I'm Carlo Taticchi and I'm going to present this work on labeling semantics for weighted argumentation frameworks. I'll start introducing some background notions on argumentation theory, then I'll present our approach to a weighted labeling, and before concluding I'll also show you a working implementation. First of all, an abstract argumentation framework is a directed graph in which nodes are called arguments and the arrows represent attack relations. The goal in this framework is to identify a subset of arguments that share some good properties. For instance, we can look for arguments that do not attack each other. Subset of these arguments are called conflict-free extensions, as the singleton A and C or A and D together in this example. But you can use different criteria called semantics to obtain different subset of argument. An admissible semantics, for instance, only accepts arguments that are defended. In the example, A and D represents an admissible semantics since A is not attacked and D, that is attacked by C, is also defended by A. There are a few more of these semantics that I'm not going to discuss now because of time constraint. An alternative approach to extension-based semantics is provided by labeling functions that mark the arguments in the framework according to some kind of rules. And there exists a correspondence between extension-based and labeling-based semantics. For example, here you can see two conflict-free labelings, in which if an argument is labeled in, represented in green, then it is not attacked by any other in argument. And if an argument is out, represented in red, then it must be attacked by at least some other in argument. And for what concerns the admissible labeling, if an argument is labeled in, then it is only attacked by out arguments, and the condition for out arguments stays the same as before. Finally, in a complete labeling, we also want any argument that is only attacked by out to be in. For instance, here we cannot leave the argument E undecided. It must be in. And classical frameworks can be then enriched with the additional information of how strong each attack is. And in this case, we need to reinterpret the notion of defense. For example, it seems quite reasonable to think that the argument C, that is attacking D, cannot be defended by argument A, since the attack of A toward C is of 2, while the attacks of C towards D has a strength of 4. And however, if we consider the arguments A and B together, their overall strength of 5 seems sufficient to beat the attacks of C towards D. And this is an example of what we want to obtain, that is a labeling for weighted argumentation frameworks, which allow to identify arguments accepted by the various weighted semantics. And for instance, the two labelings here correspond to two weighted admissible extensions, since the collective defense of A and B, that are in arguments, is sufficient to beat the attack of C towards either D or E. But D and E cannot be defended together because the attacks of C have an overall strength of 8, while the collective defense of A and B only reaches a strength of 5. And let's start looking at the weighted conflict-free labeling, and we show that actually it coincides with its non-weighted counterpart. Indeed, the notion of conflict-freeness is not affected by weights, since it only checks whether an attack exists or not between two arguments. Things are different for weighted admissible labelings, in which if an argument A is labeled in, then for each attacker B of A, say B1 in this example, the combined strength of the attacks from B towards other in arguments must not be greater than the combined strength of the attacks coming from in arguments, for instance C and D in the example, towards B. And this must be true for all the attackers of A, so it also applies to B too in this example. And this is another example of weighted admissible labeling, in which we can see that the argument A can also be left undecided. And if we instead want a weighted complete labeling, then it is mandatory to also label the argument A as in. And indeed, it is also always defended by the arguments C and D. Now I'm going to show you an implementation of the weighted labeling through the Conarg web interface. In this interface, you can draw arguments and the attacks between them. Then you can select semantics and compute the corresponding labeling. To conclude, I presented labeling semantics for weighted argumentation frameworks. Actually, I only showed you 3 of them, but in the paper you can find more. And we have also seen a demonstration of how these labelings work. And for the future, we want to, first of all, use different notions of defense to obtain different kind of weighted labelings. And we also want to work on the undecided label. We can, for example, give explicit conditions to identify undecided arguments. And we can also differentiate this label into 2 sub-labels according to the don't care and don't know policies. And finally, we also want to investigate other weighted extensions and adapt them for the weighted labeling. This concludes my presentation, and thank you for your attention.